For our next problem, we're going to find the equation of a tangent line. You will notice that sometimes more often with these, they'll give you the full coordinates of the point, because if they just give you the x coordinate of the point, it can be very difficult to solve for the y coordinate. So they gave us the both coordinates. Both coordinates, as you see, if you plug them in here, will work out. It'll give you the a point on the curve. And so what we have is we want to find the slope. So we're going to take the derivative of this. And because it is implicitly defined, we need to use implicit differentiation. So I just take the derivative of both sides here of this equation, tangent of x plus y plus the derivative of secant of x minus y, and then on the right hand side we have the derivative of 2. Okay, so fine. The derivative of tangent is secant squared. I'm going to move it down here so that we can see everything. And of course, then we have both of these. We have to use my the chain rule. So then I have the derivative of the x plus y. Now, derivative of secant is secant tangent. So as we saw in another example, that x minus y goes in each of those, secant of x minus y, tangent of x minus y, and then I take the derivative of what's in the parentheses, which is the x minus y, and then the right-hand side is the derivative of 2, which is 0. So what I have here then is secant squared of x plus y times this is going to be 1 plus dy dx. And then here I have to recopy all that. And then the derivative here is going to be 1 minus dy dx is equal to 0. So I can solve for dy dx. I could also just plug in the points and solve, but I'm just going to solve and then plug in the points because that's how I do it. So dy dx secant squared x plus y, and then I have a minus secant x minus y tangent x minus y equals, and on the other side I'm going to get a minus secant squared x plus y and a plus. Now something's wrong here. Plus is going to be a minus. Oh yeah, okay, there. I knew it was something wrong. Minus secant of x minus y tangent of x minus y. So if I solve this for dy dx, I am going to have this divided by that. So sorry if it's a little bit scrunched at the bottom here. And then I have secant squared x plus y minus this thing again. So now I have to evaluate at the point. So the point was pi over 8, right? So secant, so I'm going to end up with pi plus pi over, that's going to be pi over 4, right? So I end up with minus secant squared of pi over 4. Okay, and then secant of 0 is 0, tangent of 0 is 0. Wait, no, secant of 0 is 1. Sorry. Secant of 0 is 1. Tangent of 0 is 0, though, right? So that's just going to be 0. And then down here, also, we're going to have the secant squared of pi over 4 minus 0. So eventually, we get -1. Okay. And so if I stick that in, so that's my slope. So now I'm just going to erase this bit. So my equation of my tangent line, y minus pi over 8 is -1 times x minus pi over 8, or y equals minus x plus pi over 4. So let's take a look at what this looks like, just because sometimes it's fun to do that. Okay, where was that? It's not the right thing. Apparently it's not working, so hold on. Okay, whoops, give me a second. Of course it would be not working. Yeah, okay. Let's try that again. Try it again. There we go. All right. So here's the crazy, it's kind of a crazy looking graph, right? It's got these little breaks in it, but you see it's complaining about that. If we go a little bit closer in, it'll resolve those. So it'll figure out those. It's basically, those are going to be the points where it's pretty close to some kind of asymptotically strange behavior there. I don't know why it's not giving me this as a nice, it's not. All right, well, never mind. It doesn't, it's not quite right. But anyway, so here's my line. And as you can see, of course, you would expect, because it's tangents and secants, that there is some kind of, periodicity. It's kind of a weird periodicity, but you can see there's multiple points where that line is tangent. All righty. That's that example.